My name is Arif Malihi, and in today's session, we're going to go through some electrical circuit analysis problems regarding mostly resistors and some of the conventional and non-conventional current direction. So let's get started. So we start with this first problem. If you guys want to be more precise, feel free to pause the video, think on that, and then unpause the video and see the answer and listen to the instructions that I say. So the question is, which direction do both conventional current and the electrons in this circuit flow? For those of you who remember the first session, we were talking about the conventional direction of currents. Although positive charge never moves, however, in electrical engineering, the conventional direction of current is always the direction of protons or positive charge. On the other hand, the proper and the real direction of electricity is the direction of electrons, and the electrons, which is the negative pole, always go in the opposite direction. So this one is like the conventional. This direction is the reality. Okay? So which option? I would say option D. The current and electrons flow in different directions. The current flows counterclockwise, as you can see here, counterclockwise, which is this direction, while the electrons flow clockwise or CW, counterclockwise or CCW. Perfect. Let's go to the second example. So you see two resistors are wired in series, R1 and R2. It says the second resistor has twice the resistance as the first. We can say R2 is 2 times R1, right? Has twice the resistance as the first. Current passes through the combination. Compared to the current through the first resistor, the current through the second resistor is, so the question is asking I1 or IR1 versus IR2. Which one is greater, IR1, IR2? If you remember, the last session we were talking about resistors in series and in parallel. And one of the main features of resistors in series is that the current passes equally through all the resistors. Doesn't matter how many resistors we have in series, they will always pass equally. So the answer is the same. This one is very interesting. It says the diagram below shows combinations X, Y, and Z of 3 identical resistors. So these resistors are all the same value. I can just call them R. So R, and R. Same story for combination Y and combination Z. The question is asking to categorize them from the lowest resistance all the way to highest resistance. So which combination has the lowest resistance and which one has the highest resistance? Let's start with combination X. How do we figure out which one has the lowest, which one has the highest? I can say we just calculate the equivalent resistor for each combination. So let's go figure out the combination X equivalent resistor. It has one resistor in series with 2 parallel resistors. So if you remember, I said if we have n resistors, n equal resistors in parallel, the equivalent would be one of them divided by n. So here we have two resistors in parallel, so the equivalent is R divided by 2. And then it will be in series with another resistor, so the equivalent is R plus R over 2. That would be 3/2 R. Let's go to combination Y. We have two resistors in series at the lower branch, and you know resistors in series add up. That would give me 2R. And then this 2R is in parallel with the upper R, because the heads and the tails are connected to the same point. So for combination Y, I have R in parallel with 2R. I told you how to figure out two resistors in parallel. It's the multiplication of them, R times 2R, over addition of them, R plus 2R. That is 2R squared over 3 times R. So 1 R crosses out. The answer is 2/3 R. And finally, let's go to combination Z. This one is easy. There are 3 resistors all in parallel and all identical. So again, using this formula, if we have n resistors in parallel, the equivalent is just one of them divided by the number, R divided by 3. So that's the Z combination. This is Y combination, and here is the X combination, equivalent resistor. So which one is the lowest? That's right, Z is the lowest. And which one is the highest? X is the highest. And Y is in between. So Z, X, and Y. Z, X, and Y. Z is the lowest. Sorry, it says lowest to highest, so we can go with Z, and then Y, and then X. Z, Y, X. D is the correct answer. Now let's jump into one tricky one. This question says, if we have a number of identical 7 ohm resistors, so in this picture, each one of these resistors is 7 ohms. And it's set up as described in the diagram. What is the total resistance of the circuit rounded to the nearest ohm? So we round it up if the numbers are not neat. So let's very quickly solve it. Each one of them are 7 ohms, and these two are in series. As we know, resistors in series add up. 7 and 7, these two add up to 14. We have the same configuration here. 7 and 7 add up to 14. And this one is alone, so I just write 7 ohm for the reference. And these two are in parallel. You see, the heads and the tails are connected. 7 and 7 in parallel. Just told you, if we have n identical resistors in parallel, the equivalent is one of them divided by n. So we have 7 ohms. That would be 7 divided by 2. That would give me 3.5 ohms. So these two parallel equivalent resistor is 3.5 ohms. So now the equivalent resistor of these two is in series with this one, with this 7 ohm. So 3.5 plus 7, I try to be as clean as I can. That would be 10.5 ohms. And look, this combination here are in parallel with this combination here, which is 14 ohms. So 10.5 and 14 are in parallel. And I just told you, if we have two resistors in parallel, the equivalent is easy. So multiplication of both, 10.5 times 14 divided by the addition of both, 10.5 plus 14. Just very quickly going to calculate this one. That equals 6. Okay. This branch, which was a very busy branch, equals 6 ohms. The whole combination of these resistors. If we look closely, this busy branch is in series with these two resistors. That the equivalent resistor is 14. So 14 and 6 are in series, which makes it easy for us to calculate the final answer of this question, 20 ohms, option B. Thank you very much for watching me. If you liked the video, if you think it was helpful, please like the video and share it with your friends. Let's help each other grow. Thank you very much. Have a wonderful day.